Hello, everybody. Thanks for joining today. My name is Andy Saylor, Kilo Fox 7, Victor Oscar Lima, up here in Linden, Whatcom County, and happy to be here presenting to you guys and sharing our Whatcom County digital radio. Before we dive into this, I want to introduce the other people I have with me here today. And Bud, let's send it over to you.
Yeah, Andy, thanks. This is Bud, WB7FHC, and hopefully you just saw a video of me talking about the boards that we're going to see Andy put on today. So hopefully you already know who I am. How about over to Steve?
Hi, I'm Steve Magnuson, AG7GN from Bellingham, and I work with both Bud and Andy on their various projects. And I'm the guy responsible for the ham pie image that's been used or is being used on the Nexus DRX board. Off to Peter next.
I'm Peter Dahl, WA7FUS. I live in Briar, and I'm a long time friend of Bud's.
Yeah, absolutely. So we're really thankful to have this opportunity to share with you a little bit about what we're doing up here in Whatcom County using Bud's a product that he produces, the DRX board, working with Steve on the image, and then taking all those components, being able to put them together and help be able to service the community. So that's really important to us, and we've had some, what I feel is some good success for that, so we want to share that with you today. All right, so what we've done today is we've thrown together a picture kind of slide deck that kind of walks you through our deployment through our different sites. There are many different deployments in the county, but the ones that we're going to share with you today are primary deployments that have to do with the remote access only. They play very key roles, so we're going to walk through them. So this is the Whatcom County Digital Radio, and then what's important to understand about these is these are all unmanned stations. So from anywhere in our county, any of our ham radio operators, they can remotely access these machines through conventional internet, public internet, or through ham WAN or other ham access methods. So if we take a look at Whatcom County today, what we'll find is we already had a fairly good MCOM WinLink presence, and that's what this image depicts or represents. What we did from that point is we took the stations that were already in the county, we looked for pockets and blind spots, and we understood where they were, and we tried to figure out ways to use these machines, these boards, and these remote radio stations to backfill those blind spots. So once you get the DRX board from Bud, and Bud's already talked about that, he does a really good job of packaging it. You get the board, you get all the components. You can see there on the right-hand side, you get his well-built instructions. The building of the boards, once again, it proves to be very successful. And it makes for a nice, good unit. He's put a lot of time and energy into it. There's just a quick example of what a couple of the boards look like. These are two packages, two kits that have been deployed into our different sites on image. Here's another shot. There's Ed in the background, A7QD, and then Bryce, N7BTS. Okay, once the boards are built, this is just a glimpse of what it kind of looks like to start rolling the components into one of the racks at the remote site stations. What you'll see is the power supply there on the left. In most of our deployments, we always kind of gravitate to the Kenwood TMV71, and we can talk about that a little bit more. I like to put the pie just up there in the right-hand corner. I'll leave a little fuse panel down there on the bottom right. We start building and putting things together. And that's what it looks like in its early stage. This is one of our early Rev1 machines, Rev1 boards, setups, racks, I should say. This is its new implementation. You'll see there'll be the space there on the left-hand side. That's where that power supply would go. That TMV71, I always like to get that right front row and center. Raspberry Pi with the DRX board and the sound card there on the right-hand side. But one of the tools that I think makes this whole project very successful, and it's the bottom center, that's that red board, allows us to really take control as a user or an operator and power cycle either the radio or the Pi if something hangs. Steve, if you want to talk a little bit about that board, I know you were a key person in making that work and successful.
Yes, it's a very simple design. It has an Ethernet port on it and two relays. And it has a very simple operating system, probably a very slimmed down version of Linux on it. And you can configure it to work with a cloud server. And that's what we've done. I've set up a server on Amazon Web Services. And it's in constant communication with that server. And then a user can go to the web interface also on that same cloud server and be presented with a web interface that allows you to toggle on or off either or both of those relays remotely. So it's very handy for taking the radio or the Pi offline and then back online again.
Even though we have not had, that I'm aware of, any type of immediate failure that required us to log in to kill that, if there was a spurious emission of some sort or another, I think having that device built into this rack has really given us a lot of peace of mind. As the boards start to get done, this is one rendition of what it could look like. You'll see that relay board. I built them in just different layouts, but it's in the very bottom right. And then what it does is those one of the relays on that board controls the solenoid, or not solenoid, the bigger relay, which powers down the radio. And due to the Pi not being very power hungry, the relay board actually powers down the Pi directly. The second relay that you see there on the left is actually connected to the rocker switch on the front panel, and that kills the whole panel. So if you came up and something was going on and you just wanted to shut the whole panel down, you throw this top switch, it would pop that relay, and then the whole board would shut down. And like I said, the second one is controlled by the board, which shuts down the radio because it's got a higher amp draw. In our most recent kind of what we want to call a Rev 2 or Rev B Rack, I guess, if you will, what we found is it was more valuable to move this HDMI USB port and the acrylic faceplate from the old location, which was here on this side, which was very kind of weak in the acrylic, to what we do is we moved it over to the other side, and it was in the center acrylic, and it was better supported, and it had a better representation on the front. This port allows the user, if they're doing service work or kind of any checking up on the Pi, you can show up. If you have a little portable monitor, you can plug directly in, plug a little USB dongle for a mouse and a keyboard, and you can operate the machine right there directly if there was something wrong. So that was a little change we made down the line. So, all right, so let's start jumping into what the digital machines are, which ones they are, and where they are. The first one we're going to talk about is W7JIM. This machine is located in Ferndale, up on top of the hill. The Church Road site, we call it, and it's actually in the Ferndale Fire Department. It's actually lives with the repeater. So if you were to look on aprs.fi or APRS Direct, what you would see is if you typed in, we use a tactical call on this site, and it is set up as church. This machine operates 24/7 primarily as an APRS iGate and digipeater, and it performs quite well in the county. This is a glimpse of what it looks like. Once we log into the that machine remotely, we can do this with two different services. We can use either VNC Connect, which we found works very well, or a secondary solution that we've been using more recently, which is DW Services, and it's been a good solution as well, and it yields us some other successes that VNC does not. But this is what it looks like, just a snapshot of inside that computer, and you can see it's currently running as Digi iGate, so that's what it looks like. Once you get on site, this is the installation at that site. What you'll see there on the top is that's actually one of Whatcom County's Brandmeister repeaters, so it works very well. But most importantly, down below it, you'll see our analog, Whatcom County's analog repeater, and right above it is the digital remote access digital machine. So this machine was a little unique in the sense that it does not have a power supply on it. We were able to utilize the power supply that was already in sight there in that rack station. So that was a little look and glimpse at our church site. And one thing that's important to note about this machine is its primary role, idle, is APRS and Digi iGate. but we can log into it at any point in time, shut that APRS functionality down, and do FL Digi operations out of it. So where we do FSQ and MT63 along with other modes as well. So it proves to be a great asset. The next one we're going to talk about is W7WWU, and this is our Western Washington digital machine. We use this one primarily as an APRS iGate on a 24/7 kind of basis, and then as needed, we can shut that iGate down for APRS, and we can do FL Digi operations as well. So if you look at the Whatcom County map, under the APRS.FI configuration, you will see that it presented just as that. And this machine as well, we use a tactical call. We just go straight with WWU. Once we log into that machine, this is a glimpse of what you'll see. This is kind of the background. And then the window that you see open there is the APRS.FI, or the APRS iGate traffic as it's coming in. And Steve, correct me if I'm wrong, that's a lot of that's handled by AX25?
Yeah, it uses Direwolf TNC. Yeah, right. And then there's Direwolf configured as an APRS iGate. That's correct.
You have a question, bud?
Yeah, I think we should hear from Peter. Both Peter and I are alumni from Western Washington University, as Western Washington State College when we were there. What do you see of this picture? Do you recognize any of it, Peter?
Oh yeah, I recognize a lot of it. Recognize a lot of what used to be green space is filled up with buildings now, but it's a beautiful campus. I keep on enjoying going back every time.
We love being able to partner up with these facilities, and I think it allows a lot of different people. One, these are great sites. Two, people have common histories with these sites and a lot of interests. And this one is really, it felt good to be able to build this and grow it and get this online. So in this picture, just as a reference, what you'll see is down here just on the edge of the shot on this main building is where the two antennas are. And I'll show you a picture of what it looks like, but that's actually on the ground floor is where that station is located. And it has an incredible view to the north of the Bellingham area. So it's a very strong machine. So in one of the offices where the antennas for this particular site were already mounted, at one point in time, they already had a great group of hams, saw the need to install some antennas, run some coax, and I think they had a group at one point in time. The radios and the components had left, but the coax was still there and kind of plumbed out through the wall through a conduit. And that's what we became aware of, and that was what we worked towards to try to utilize. When you open up the box, this is what you'll see on the modern machines. In today's application, you'll see that Kenwood TMB71. Why those are so important for this project is even though they aren't historically a rig control machine out of the box, something that's advertised, they do allow a rig control capability with the use of the Raspberry Pi. So through some great work with Steve, he was able to do some work, and I'll let him talk about that.
Yeah, the rig control capabilities of the Kenwood are implemented on the Raspberry Pi or accessed from the Raspberry Pi using the HAMLib package, which provides an application called rig control. And I wrote a shell script that interfaces with the rig control. So if you have remote access to the Raspberry Pi, you can open a terminal and change frequencies, change power levels, and access memory locations and a variety of other things to manipulate how the radio operates. So that's how we access the radios remotely, change frequencies and modes, and it works pretty well. And we have this deployed wherever we have a Kenwood 71A.
Absolutely, absolutely. No, and it took the first initial install where we couldn't change frequencies, and as the DRX board's abilities grew, and we learned the things that it could do, and continually growing, it allowed us to follow that growth. And so now having the ability to change frequency remotely really took these stations to the next level.
Andy, a question for you.
Okay.
that RJ45 jack that you pointed out just to the left of the radio there, that, just to be clear, that's for plugging in a microphone so you
That
can
is
operate
correct.
voice?
Yep,
Okay.
yep. So you don't see it in this picture, but yeah, I typically like to try to leave a mic at the station. I leave it unplugged, so that way somebody doesn't get into it and say, hey, what's this, and start keying up by accident. But I make it available if there's some type of event. It could become a voice access station.
Okay.
Yeah, good question. These are the antennas that were already installed at this site. We felt very lucky to have access to these. One of them set up in the VHF ham band, and the other one's in VHF and the commercial bands.
Yeah, Peter, you and I are going to recognize these antennas as these are AEA isopoles, right? And these are the antennas that we were using in our original digipeaters clear back in, was it the 1980s?
Yeah, sure was. Yeah, EA Isopoles, one of our partners in crime for the digipeters and so forth years ago was John Gates and 7BTI with AEA. And the antennas were designed by UW professor Dr. Reynolds, who did the design for AEA and had the patent and so forth. And they manufactured them in Linwood.
Yeah, so either way, I didn't know the history, but was extremely impressed of the performance rapidly. I know as an iGate, it's not really leaned on heavily, but when we roll this machine over to FL Digi and transmit for FSQ or MT63 or one of our digital modes, it performs very, very well. So it's been a great test. The next one we're going to talk about is KB7TEC. And this is the station that we got mounted up at the Bellingham Technical College, and it's their digital machine. The primary role for this machine is a little different than the other two we just talked about. This one's, what it does on a 24/7 basis primarily is as a WinLink RMS node. What we saw is we did have a node or two that were near the Bellingham area, but there were still a lot of shadows. We found that's where it seemed like the larger amount of our user base was. So we wanted to do everything we could to try to strengthen that environment in some type of MCOM instance. So that's why we targeted this location. That said, we do, through the HAMPI image, it does give us some incredible ability. Under limited periods, we can shut the WinLink node down. We can perform digital FL Digi communications and then fire the WinLink node back up as well. This one is located, WinLink always shows the stations a little off. That's their general nature, but it is actually located there at the Bellingham Technical College, which is just kind of north of the Bellingham downtown area. Once you log into this machine, this is a glimpse of what it looks like. What you'll see in the text box is a visual representation of what's going on in the background with RMS Express. For me, this station, when it's designed to auto boot and on power up, it boots up all these components and these systems in the background, and it runs. As a user not having a vast knowledge or base in how this stuff works, I thought it'd be important to be able to visually see kind of what the node was doing and the traffic it was handling. So Steve made some adjustments, and it came this log viewer window. And I don't know if you want to talk about that, Steve.
This is just a script I wrote that brings up a window and monitors certain log files that the AX25 and RMS Gateway programs write to, and monitors them in real time. There's also a button there at the bottom, Start Stop RMS Gateway. So if you press that button, another dialog comes up and gives you the opportunity to either start or stop the RMS Gateway in case you want to operate FL Digi or some other application instead of running the gateway.
Absolutely. And for me personally as a user of these machines, this was huge. It allows me to be able to pop in at any given time, kind of look over the shoulder of the machine, if you will, see what the traffic it's handling. I could go ahead and send a WinLink message to this machine. I could review how that message was received, and like to your point, shut it down to do emergency digital operation as well. So it proved to be very, very valuable. Another thing that makes that successful is having that access to that D7100 to change frequencies for those different process. So once we get at the site, this is what the installation looked like there at the technical college. This ended up being the location they liked. So we went ahead and mounted it right there to the wall. So that's a look of the rack already fastened to the wall. They did the installation of the box themselves, and then just let me know when it was done, and then I was able to come by and mount the components inside of it and run the rest of the cabling. It's a little bit closer view, right, to the box, and it's set up in a very similar way as the others, right? This is the one that I showed earlier that has the HDMI and USB port on that far side. I since have moved it and I put it on the other side in between the radio, and it's proven to be a little bit more robust of an install location. We're still running the UPS, the network switch, and this one still has all the other functionality with that little board that allows us to remotely power cycle the radio. So very, very similar, if not identical application as Western. On the rooftop side of things, we came up, that hole actually brought us inside of that piece of structure, and then we were able to mount our antenna system to that. They already had this little electrical box cover plate. We mounted a little pass-through and put a nice little drip loop in it and ran up. This was a bracket the college actually had that we utilized and put a nice medium gain base antenna on it. Performs quite well. This station in an RMS configuration, watching the traffic today, it handles traffic from the northern Surrey area, Linden, Everson, down south, and there's a fair amount of traffic it handles out in the San Juan Islands, primarily Lopez. So this is one of our more busy machines. And this is actually one of their northern buildings on the site, is the metal shop. So the next one we're going to talk about is K7SFV. The primary role for this one is WinLink RMS node, and it does not have a secondary task today. Yeah, go ahead, Peter.
Does that area where that is, the unique area, already have coverage for APRS?
It does, actually, and that was something that I looked at. I would like to upgrade this device. This one's built a little bit differently than some of the others, and we'll talk about it. But so Lenny and WA7LA, Steve, correct me if I'm wrong. WA7LA, I think?
Yep, that's correct. Mm-hmm.
Yeah, so Lenny has an iGate on the South Lake Whatcom area, and his iGate performs very, very well. And geographically, if you look at the location of Lenny's machine in relationship to ACME, they're actually very close. And he would handle the majority of that traffic that I'd be handling as well. So we'd be fighting over managing the same thing. It wouldn't hurt. The joy is with iGates, it doesn't hurt anything. But currently, the way this machine is built, we don't have the capability to change frequency, and I'll show you why. So if you'll see down here on the map, K7SFV, that's where that station is located. And if you look and you follow my cursor there in Sudden Valley, in this general area is where Lenny's iGate is. So it really does handle any of that traffic that comes through there. So once you log into that machine in a similar way to we log into the others, either through VNC or DW service, this is what you'll see in that one. You see WinLink RMS node running here off to the side, and just a very simple representation. This is the very humble fire station there in ACME. What's good about this station is it's right smack dab in the middle. It's right on Highway 9, and it sees all the way down to Cedar-Woolley and all the way up to Deming. So it's as much as it may not get a lot of traffic geographically, to close that gap, it was the best location to do it. In this application, there was space was a little bit more limited. So we found ourselves once again back in a little utility room, storage room, which is okay. We could see in this picture here, we ran our cable runs over. We were able to push them through a pass-through. Just another shot of the box just over the doorway, the power there. And the inside before the rack was mounted. That one is after we got the rack in there. Let's see if I have another picture. I don't. So What's important to note on this in this shot is we did a little bit different install on this particular site. We used a Linko DR135. Now that proved to be a very, very strong digital radio. I've got a few of those and they work very well. The downside was it does not allow rig control capabilities. These projects are not publicly or funded in any way other than myself. So I actually ran out of TMV71s. That's the short version. And I wasn't sure that there'd be a big need for, I had to be able to roll this one over to do FL Digi in today's environment yet. So I went ahead and I installed it, and the configuration it has here today. It still has all the same capabilities. If somebody was there on site and changed frequency, we could still do everything that the other machines do as well. I'm just not able to do it off. I'm not able to change frequency off-site. I always kind of, when we start to partner with a facility, I always get a little concerned about, hey, we'd like to drill holes in your wall in your facility for this thing, and I was followed by, for what? So consequently, the fire chief at the ACME Station was great about it. He loved the project. He loved what we were doing, so he was very, very accommodating. So it was very beneficial. Outside, we tried a little bit different antenna application. We used some Unistrut, and we actually tried something new. That's a Ed Fong dual band in the low pressure PVC pipe, and we got it mounted up into that little piece of conduit there and used that Unistrut, and wasn't quite sure how it all was going to work, but after it was done, found out that it made for a very, very clean install. It performs well and supports that area good. So it was a great budget-minded solution. One of the things that was a concern, oh, go ahead, Peter. Yeah.
If a community group outside of your area wanted to duplicate these and start putting them around to various places in their counties or whatever, do you have a ballpark price as to what it would cost per system to duplicate the ones with the V71 and be from nothing to totally operational?
Yeah, that's a great question. I should have done my homework on that one and had that ready. I think first and foremost, every site's a little different, right? So you can get lucky, like in our Western application, and they already had antennas and coax cable runs ran. Even though that was a longer run, it was already available. Or you could have other sites that where you got to run everything, right? You got to run 100 feet of network wire. You got to run another 50 feet of coax. You have no antenna solution, so you have to add that. To be safe, I think I've built these for probably as little as $500 for a complete station. I say real world, if you just had to build it tomorrow and you wanted to go order all the parts and pieces today, and you had to run a little bit longer distance, call it $750. But it's going to be in there. If you really do your homework, you might be able to get one built for $5. A good question. So that's a glimpse of the antenna solution. One of the big concerns here for this site was whether we were going to have any interference with the fire frequency. So to my knowledge, they're operating at about 155, anywhere 1.6 to on up. They're in that kind of 155.1 window megahertz. And in our normal application for this particular site, we're 144.930. So there was we tried to create as much vertical separation as possible to ensure that we weren't going to have any issues. And so far, through all our testing, we've been okay. So that's been a good success story there. So all in all, those are the 4 primary sites that we have today up and running. We have a couple others forecasted that are on the horizon. But under our current environment, that's closed a few doors. In some ways, that's opened a few as well. But we're going to continue to grow, see where the shadows are in our counties, and continue to use these DRX boards to support the public. If you'd like to see a full unabridged version of this presentation today, please look for that on Bud's YouTube channel, WB7FHC, where you can see the full documentation. All right, MicroHAMS and all the great viewers out there, thank you for sitting in on this, and back to you.